Hi, good morning, everyone. We're going to start with the demonstration of our mobile offloading application. Here we have a landing screen where the user can choose to act as a master or slave for the session. And here we have the master setup screen. The user has a few buttons here where they can publish their service discovery, and that will allow a slave to locate the master and connect to them. So here we can see we have the slave screen. So once the user gets in, they have a button to start looking for nearby masters for which they can connect. So now you can see here it's found the master, and once it sends the connect request, then this is the service discovery portion. A permission dialog comes up, and the slave connects to the master. Now on the master user interface, there's a drop-down button where you can monitor the different slave devices that are connected. And there's also a button which allows you to go into the log where it logs the battery and location information from each of the slaves. So now we're going to show connecting a second slave device here. We'll go ahead and publish the server, and we will find a nearby master. So once it's located the master, then it has the option to connect, whereby we see the dialog box again, and the master connects the second slave. So now inside the master, it has the options to publish itself. It has the options to open the log. It has battery, latitude, and longitude where it can monitor the slave devices. And here we have it connecting a third slave. So it'll accept that request. And last, we'll show it connecting of slave number 4. So once we have 4 slaves connected, you can see all those devices are listed in the drop-down menu. And with each of those, we can open up and look at its device information. And so we log all the information from each of these slaves inside the slave log, which the master can identify, and it can get all the relevant details for each of the devices that are connected, and get a good overall picture of the network that it's developed here. Also, the slave log is append only, so all of this information is.
All right, so now we'll be talking about just the happy case part where all the slaves are ready to compute their part. So just the task, how the master divides is, it assigns a particular like first row, first column to first slave, and second row, second column to another slave in a round robin fashion. So as you can see in the right screen, slave 1 is doing its computation. So all this slave 1, slave 2, slave 3 doing in parallel basically. And so you can see this result also on the toast. And also once all these tasks are finished, you can see the finish time on the right screen that is finished in 11.883 seconds. So once all these results are done, they'll be sent to the master, and master will be waiting on that. As you can see, the total time it took is 11.8 seconds, and power consumed is 1.3 milliampere. The rest of what is pending is, so this is our slave log. So basically every slave log, what it did, and what is the battery power is all logged here. And just verify the results. Verifying the results is like master computes the matrix multiplication again, and this is the matrix, difference matrix. Basically, this is the difference between the master and the slave computation. If it is 0, then it all went fine. And here you can see that this is the master computation risk just for verification purpose. So then also we have logs for individual slaves, which we will show in the next screen. So for example, slave 1, this is slave 1 particular computation results. So if you scroll down, you can find all slave 1 computations. Same for slave 3. These are all individual computation results.
So now we look into the failure case. The scenario that we're trying to mimic here is when one of the slave devices connected to a master gets disconnected midway of computation. As you can see here, in this scenario, we have 4 slave devices connected to a master. Here is the list of all the 4 slave devices. We'll begin with master computation to show the results of the multiplication on the master device itself, which is here. Now you can see that we have started the slave computation, and on the right you can see the slave devices, 4th slave device connected. Now as you can see, we press the disconnect button midway of the computation, and on the right you might have noticed a slight difference in the list of computation on the slave 4 device has been eliminated from that list and the computation carried forward. And now you will see the results in a verify results section. As now you can see that we have a matrix which is not entirely zero matrix. We have some negative numbers. This is due to the case that we disconnected the slave 4 midway of the computation. So some of the computations that were passed on to the slave 4 came out to be negative in the difference. But this does signify that our system is full proof of the failure case, since it localizes the failure and does not disrupt the entire system. We are still working on the failure case and will improve the results in the next submission. Thank you.
Hi, coming to the code walkthrough. Our startup activity is the info activity, and here we ask the user to enter the server name and also to decide whether the server is a master or a slave. And then this information on a button click is passed on to the main activity, where we come to the onCreate function. We set up the UI differently for both the master and the slave, and start with the process. So to start the service discovery, first the users click on the button for start advertising and start discovery, and once that is done, the slave and the master are set up with callbacks. So first, the important callback is the connection lifecycle callback. In this, on connection initiated and on connection result and on connection disconnect options are there. For the initiated option, we basically, other than the UI part, we do show alert dialogues to both the master and the slave to decide whether to accept or reject the connection. Once that has been established, from the master side we don't do much, but from the slave side we generate a slave object and send the battery level and the locations of the slaves to the master through a payload. And we also set up a timer task to keep sending this information regularly. Once that is done, the connection has been established. On disconnected, I will come to later. On the endpoint discovery, which is from the slave side, we initiate the request connection. So these are the two important callbacks. Once this is completed, we go to the, as we have already sent a payload, we go to the payload callback. In the payload callback, as we sent no information with result from the slave, we enter this particular section, and in this we check whether the battery levels are sufficient and the distance is sufficient, and then start writing to the file, and also added to a dictionary for to use for calculation later on for the matrix multiplication. If the battery levels are not matched, this part is the failure recovery, which I will come to later. But we do send a slave information from master to the slave with dummy name as disconnect, and on the slave side, when it sees that a disconnect dummy name is there, it automatically disconnects from the master, so that only the ones with sufficient conditions are used for the calculations. After this, once that is completed, we have an option to do the matrix calculation on the master or the slave. On master, it is straightforward. It does the direct normal multiplication on the master and also checks for how much battery and time has been consumed. Coming to the compute and slave, used a round robin approach for this. So obviously we start with the time and the battery first, and then we split up the matrix from the master into various chunks based on indices, and based on what all slaves are available to us in the dictionary. After the connection has been established, we populate the matrices of those particular slaves so that they can calculate, and we send this slave information from the master to the slave so that they can start with the calculation. So once that happens, we come to the slave side, and on the slave side, we check if the computation has started or not, and if it has not started, we start the multiplication of what the information from the master has been sent, and send the result back in the payload to the master. Now the master receives this result, and what it does is it calculates the output. So based on the indices, it populates those indices from on the master, and writes some the information to the file. After this, it checks whether the computation is still pending. If it is pending, again the slave matrices are generated and sent to the slaves which are empty. Otherwise, if the slave is complete, the battery monitoring and the time monitoring is stopped. The final result is calculated, and then that the computation is completed, information is sent to all the slaves using slave send again. So this way the matrix multiplication keeps going on as information from the master is sent, and then the slave does some calculation, sends it back to the master, and the master in a round robin way quickly assigns information to each and every slave. So after this emulate the failure recovery, we have a on disconnect button, and also we have another option where if the battery suddenly goes below 20, we send this information, as I mentioned before, to the slave, and it disconnects automatically. But once an on disconnect is called, we come to the on disconnected, we get back the indexes which it was trying to calculate and add it to the list again, because this has not been completed. And also we remove the information of the slave from the dictionary so that it is no longer used for calculation. Then the calculation continues as the slave list has got back the result from that particular slave, and then it again sends it to an available slave for calculation. This way failure recovery is handled. Finally, to get the information on the matrices, we have and the slaves, we have two options for a button. One button takes us to the slave log activity, which basically is used to read the log files of what all the battery monitoring has occurred, and the other is the verify activity, which uses which takes the slave matrix and the master matrix and checks whether both the computation results are same, which shows us that the computation of both the slaves and matrices has happened correctly. Also, we display the matrix for reference.